Alright, so here we're going to go ahead and do another type of problem here. Similar idea. We're given that f is the inverse of g. We're given the equation for f of x. Find the equation of the line tangent to g at the point 8, 2 on g. Okay. So as we're looking at this one's actually a little bit easier than the last one. So if we're setting this thing up, we want to find the equation of the tangent line to g at the point 8, 2. Right? So remember, that means that we need to find the equation of the line. So we need two things. We need to have the slope of the tangent line to g at 8, 2. Right? So we know from our previous work that the slope of the tangent line can be found by doing the derivative of g at that point. Right? So we don't have g here, but we do know that g and f are going to be inverse of each other. So we can use the work that we did earlier to go ahead and say that essentially we want to find what g prime of 8 is. Right? So we know that's going to be 1 over f prime of g of 8. Right? And so in this problem, we actually are given g of 8 over here, which is just going to be 2. So this is essentially saying what is 1 over f prime of 2. Right? Once again, we don't have f prime, but we can go ahead and find f prime by just doing the derivative of f. So we get 3x squared plus 2. And we're actually looking for what f prime of 2 is, which gives us 3, and we have 2 squared plus 2. So we end up with 4 times 3, or 12 plus 2, or just 14. Right? So when I go to plug that in, I end up with 1 over 14. Right? So that's going to be the slope of the tangent line to the curve g at the point 8, 2. But remember, we need the equation of the line, so we also need the coordinates. So point slope form would be the best because we have the slope, which we just found, and the point over here. So this would end up being y minus 2 equals to 1 over 14. That's the slope. And then times x minus 8. And it's done.